Okay, so now we're doing part 2. Let's go ahead and run through that. We have this graph. We want to read off these two pieces of information. The graph is the function w of x. This is just saying find w evaluated at 3, so I just look over here and I see it hits the value -3, which means this takes the value -3. For the w prime of 3, the derivative at 3, I need to look at the tangent line and figure out the slope of that tangent line. So notice that we can use, well, we should use this point, and then we've also got this point on the line. And so this is a slope of 1. So that means that the answer for part B is 1. For number 7, let's see. H is the height of water in inches inside of the rain gauge hours after midnight. Okay. Explain the meaning. Okay, so we just need to interpret things. Right, so height of water is important, hours after midnight is important, and then do we need to talk about rain gauge? I don't know. All right, so what does this statement mean? So in inches. Right. At 5 a.m. We can say 5 a.m. Yeah. Rain gauge height is 1 inch. That's basically what that says. And then, okay, the rate of change at the 10th hour. So at 10 a.m., the change, or we can say rate of change, or maybe that the height is changing at a rate of, yeah, okay, yeah, height of water in the rain gauge is changing or increasing, really. Yeah, okay. I prefer increasing than changing. Increasing at a rate of 1/3 inches per what hour? This is in terms of hours, yeah? Yeah. Okay. Yeah, so that's what B is saying. Alright, number 8, given that v of 3 is 7, v prime of 3 is -10, find an equation of the tangent line, blah blah blah. Okay, yeah, so it gives you all the data. So what you just need to know is that this is the slope. So the derivative is the slope of the line, and this is actually the point that lies on the line, the point 3 comma 7. So we're given m is -10, we're given the point, and so we just write the tangent line in point slope form. So that is y minus 7 is equal to -10 x minus 3, and that'll be it. Don't have to do anything extra. Okay, and then for 9, let f of x equals this. Using the limit definition, find. Okay. So we just need to use the limit definition, and we want to find f prime at 5. So this is the version of the limit definition that is not the abstract one. This is the one where we have like a in it. So limit as h goes to 0, f of, normally this we would say a plus h. A is 5 in this case, so 5 plus h minus f of a normally, 5 over h. Okay, and now we just crank through the calculation. Plugging it into the f function, we would have square root of 5 plus h minus 1, which is 4 plus h, minus f of 5 minus 1, so that's square root of 4, which is just 2, all over h. Okay, and so this is the limit that we need to compute, and since we have a radical here, we kind of expect to require that we use the, what's it called, conjugate. So 4 plus h minus, plus 2 over the square root of 4 plus h plus 2. Normally I wouldn't write the conjugate out, but for some reason I'm doing that. Okay, limit as h goes to 0, and then That's going to become 4 plus h minus 4 all over h times square root of 4 plus h plus 2. And then things cancel. You've got this cancellation, you've got that cancellation. You have a 1 in the numerator. So this is going to become the limit as h goes to 0 of 1 over the square root of 4 plus h plus 2. And then, yeah, we can just plug in at this point. So 1 over, and then it'll be 2 plus 2, so 1 over 4. And I suppose we can also just verify this since we now know about the derivative properties. So let's just verify that we got the right answer. If I take the derivative in the abstract, just f prime of x, I will have 1 over 2 radical x minus 1. And then if I plug in x equals 5, I'm going to get 1 over 2 square root of 4, which is indeed 1 over 4. So we verified that the algebraic calculation is correct. Okay, and that seems to be part 2.